Hello, my name is Andrew Michler. I'm a certified Passive House consultant and Passive House designer based in Colorado. It's a great pleasure to be presenting with you guys today in Portugal on Passive House and some thoughts on Passive House from my experience over the years. And I was going to present on a specific project that I've been working on for the past few years, a multifamily residential project. I'll go in some detail about not just the Passive House component, but the social component, the carbon component of architecture, and specifically how to integrate Passive House into a larger social movement and need that we have, especially around climate change. And climate change is something that's affected me quite personally. In fact, this is a map of where my Passive House is. The little star, gold star in the middle is where my Passive House home is located. And right next to it, you can see a brown splotch. Last year we had a large forest fire, the largest in where I live in Colorado. I actually live in northern Colorado near Rocky Mountain National Park. And we had the largest fire of Colorado history come right up to my property. And we're seeing just significant change extremely rapidly throughout the continental west of the United States from climate change. And, it hits close to home, especially on how we build and how we will think about building in the future around the carbon question in particular. My firm's called Hyperlocal Workshop. Some of the work I've done is mostly in the residential area. I'm working on projects from New York to California and Colorado. Happily, they're all certified projects, and all the clients are extremely keen on not just certification, but the quality of the building themselves and the quality of the space. So we look to have a really well-rounded, aesthetically significant type of design. It's experimental, but very much based on place. And Passive House works very well with that, of course, because it's so climate interdependent. I've also wrote a book called Hyperlocalization of Architecture that was published maybe 6 years ago. It's available in Europe and just about anywhere in the world. And it's also a book on kind of global projects around the world, specifically around the idea of hyperlocalization of architecture, which means how does contemporary architecture work with both the culture and the place, both environmentally and aesthetically and functionally. And one of the things I've learned of the past few years was that the way that we talk about what we call sustainable building, green building, resilient building, all these terms are often based on very specific terms that are near to perhaps our own professional goals or professional needs. But buildings are really quite complex. Cities are even more complex in the integration of buildings and cities and in places. So the way I want to kind of look at talking about buildings in this talk is kind of a broader sense of what building design does, using Passive House as kind of the core metric, as well as carbon. Passive House, even though, as we know, it's an energy standard, it covers significant other things around the health and well-being of occupants. But the social impact, the idea of urbanization, density, the materiality of buildings is just as critical. And the project that I'm going to present on is called Temporal House, and it's part of the European Cultural Center's Venice Biennale this year. I've been working on it for a couple of years, and this is a photo of the installation in Plaza Moro in Venice. And the Italian Architecture Biennale theme of 2021 was, how will we live together? That was the question. And my question back was, where will everyone go? And to frame that, this very well-written ProPublica article goes into the story of climate change and how it's affecting migration in Central America and forcing people to move north due to the change in the climate environment where they live. And I'll read this quote, for the context of where will everyone go and how we design buildings for them. By 2070, the kind of extremely hot zones like in the Sierra now cover less than 1% of the Earth's land surface, could cover nearly a fifth of the land, potentially placing 1 of every 3 people alive outside the climate niche where humans have thrived for thousands of years. And that's the reality that we have to design for. Many of the buildings that we're designing now and building now will be here in 2070. So keeping that in mind, what that social impact will be, should be very much a part of how we think about what we are building. And in this case, I was thinking very much about Los Angeles. In fact, my publisher, Ivolo, for my book, was just down the street on Wilshire Boulevard. And got quite fascinated by the street and walked it quite a bit. I did quite a bit of research on it. And it turns out to be the original strip mall, the invention of the strip mall in the Americas. And strip malls, of course, where car dependent, where you go to park your car in front of a business, get your materials, your groceries, and then jump back in your car and go down the road again to the next business. So we're reclaiming the idea of reclaiming Wilshire Boulevard back to a pedestrian place, a place for people again. So I found a funny little lot as a proposed site for this project. It's a multifamily project. It's near the metro. It's near downtown. And there's, of course, lots of tarmac, what we call parking and concrete Wilshire. So it's about reactivating that space again. And the place I started from is rethinking what a 21st century shop house would be like. And traditionally, especially in Southeast Asia, but certainly all around the world, many people came to live and have small businesses within a single building, often the storefront, and then living in the back, sometimes multiple generations. But it was a compact way to integrate the socioeconomic process of integrating into a new place for many generations of past. So the idea was how to design a building to work with that impact. And then I was very inspired by a trip to Japan, a couple of trips, in fact, specifically into Kyoto and the form factors there, which I found quite elegant, especially on the street side. And the other thing I was very inspired by, and something also I've seen lots on Wilshire Boulevard and in Los Angeles in general, is the food truck culture, which is basically taking what we call the brick and mortar and turning that into a mobile food business, which is much more realized for people from different social economic stratus. So we designed and developed a small food truck that won an architecture award, which is great fun, but also is basically an espresso bar. It's mobilized and solar powered. And I'm having a lot of fun working around the idea of mobile micro businesses. So the idea was to integrate those concepts into a multifamily passive house in Los Angeles. The building we're looking at is 8 stories. I'll go a little bit into the program later, but this is the general impact it has on the street side, where it's much more perforated than typically the architecture is. So it's opening people, inviting people in from the street into the place to enjoy. That very much is about an activating the sidewalk scene and giving people a place to sit, to congregate, to enjoy themselves. And then further alongside the building is a place for food trucks to gather, and a protected place for people to both wait in line for their food and to sit and enjoy it during lunch, during the evening. And then just kind of an aesthetic, here's an aesthetic section of what the space looked like. And as a passive house, of course, one of the first issues we have to deal with is orientation. Los Angeles, a hot, dry climate, chose a lot that was actually less than optimized, let's say, for a building such as a passive house, especially with the solar heat gains. And the west side is actually where all the apartments will be facing on the 4 stories of apartments that the building has. It has about 29, I believe, apartments in total. And they will be reserved for different immigrants from Central America is the idea, from single people to families. And from the orientation point of view, since we're facing west, we had to really be extremely aggressive on the shading on the exterior, which I know in Europe is quite common. In the United States, it's almost unheard of to do exterior shading. So that, of course, was critical component to the functioning of the building. The good form factor, of course, is also critical to the building. So compact, simplified, even if it has some elaborate projections from it, the core building itself is somewhat simple. It's what we call a single loaded building. So that means that it has one hallway on the side, in this case to the north side, and then a single row of apartments. The first floor is actually a commissary kitchen, public restrooms, public amenities, perhaps a small bar, things like that. The commissary kitchen is a place for people inside the building to actually either support the food trucks or to run their own food businesses, catering businesses, things like that. So it's very much about the integration of people's lifestyle and work into Los Angeles and provide them a means, an economic means as well. Then micro apartments, small apartments, multifamily apartments with multiple floors, and then finally an outdoor space on top, which would be great to use as a school, place to maybe even grow vegetables, in an adaptive program over time. Give you a sense of what the floor is, especially in the sense of passive house, is that because it's single loaded, we can easily provide cross ventilation in each floor from the hallway into the individual apartments. The apartments have what in Imperial 4 by 8 foot windows. They're tilt turn, of course, so they open, so they're kind of de facto balconies in that sense. The elevator shaft will give access through the building and to the roof. The mechanical is right behind the elevator shaft. The mechanicals, I have another slide that goes into some detail on that. Open kitchen, the floor plan also has an open space on the street side, so the balconies are connected throughout the building, and then shared kitchen spaces and different size apartments, as I mentioned. On the carbon side, on the material side, the proposal is using a straw panel system. It's called EcoCocon, and it's a prefabricated passive house panel. And then the podium underneath is made from cross-laminated and nail-laminated timbers. In this case, we're using a product called Lignolock, which is a wooden nail. And this actually passes code in the United States, this type of construction now, as of just this year. So we can build up to 8 stories in all timber, which is really fantastic. Also, with fire, earthquake, all those other things are considered a part of the code at this point. The EcoCocon panel actually, because of the density and the silicon straw, is actually quite fire resilient, and that's the first question people often have, is that straw must burn, but in fact the wood burns before the straw does, because of the compactness of the way that straw is packed, and because much of the material is indeed not supporting flame. So it's also quite earthquake resilient. It stacks quite well, so it's fundamentally a carbon positive and very durable, robust building system for passive house. especially even at scale, which is very much the idea of the low carbon building movement. On the timber side, the podium, which is earthquake resistant, is this product that's being developed by Beck using these wooden nails that they created, which you can build in small scale shops, even using automated systems using wood nails. We also don't need to use glues, things like that. So it's quite a strong, robust product, structural component to the building, but also earthquake resilient and something that we can easily deconstruct over time because of the lack of glue and fasteners within the slabs themselves. So that's the core of the building. Very much the mechanical systems are on each floor to simplify it. I can still use components that are certified Passive House that are now made in the United States, including our ventilation system, our windows. We were able to develop this as a Passive House premium building with the help of the Passive House Institute in the energy modeling supporting that. And the compactness of the building is quite key to its success, especially in kind of these more narrow urban lots. Now, the carbon question, I'll get in some detail about how we dealt with carbon with the building. Our ongoing operational energy is minus 130, or say a net positive 130 kilowatt hours per square meter on an annual basis. And that's due to the Passive House premium certification process using the primary energy renewable system, which is very much about both the renewables and the footprint of the building and the building density. So this is a good example of how renewables and density merge together quite well into a Passive House system. And then the embodied carbon, I did some work on developing calculations for the embodied carbon. And that's at 224 kilograms emitted per square meter total for the construction of the building. On the PV system, it's very interesting that, you know, of course, in Passive House, we like to not think about net, but in real terms of energy usage. So in production, we have to be as aware of the lowest time of energy production, which is typically in the winter as we are on peak. And I found it interesting to see that in this particular use case that the horizontal panels in summer peak quite a bit of energy, but the vertical panels in winter provide almost as much energy as the vertical system does. So overall, when we look at our peak demand needs, are well balanced with our production in the wintertime, which is an important critical component of the energy production in Passive House, which is well beyond what we talk about when we talk about net zero buildings, for instance, which are not time-based. And here's the verification chart. It was really very satisfying to see that we could develop a building that didn't actually have a real heat load need. It was just a cooling load, which also helped with the simplification of the mechanical system, for instance. In fact, I found that putting in just double pane windows raised the heating demand quite a bit, which would complicate the installation, use more energy. So the triple panes were using triple pane, even Los Angeles works quite well, because of the street noise and all the activity down below, but also because of the quality of living inside, but also because it simplifies other parts of the building, which is this integrated process that we get to learn from Passive House, how windows affect mechanicals, how it affects quality of the environment, from sound, acoustics to temperature, things like that. For the carbon calculation, I used something called the pH ribbon, which is a plugin for the PHPP that uses the RIBA's methodologies for carbon. And it's really important to understand, especially around the carbon question of the embodied carbon, what we call it, is that there's a lot of assumptions that can be left out. So finding out what a true carbon number can be quite nuanced. First of all, it starts with the materials. Timber storage and the straw, of course, is a significant long-term storage. Straw has a renewable rate on annual basis. Timber is much longer, up to 40 to 50 years to reclaim that carbon, so you have to replant forests. And also the materials at the end of the building's use cycle, if we just burn the materials or bury them, they can easily go back into the atmosphere again. So that's accounted for as well. So the idea of deconstructibility, to be able to reuse these materials, to be able to at least design and anticipate the reuse of carbon materials in the building is very important. Similar to like beautiful old brick or stone buildings or the mass timber buildings of centuries ago, much of that material can be reused over and over and over again. And what also is very surprising is that the solar electric system needs to be replaced every 20, 30 years or so. So as an ongoing basis, along with mechanical systems, things like that, that has an impact on the carbon footprint of the building over time. And then the upfront cost. The PV is actually the most significant embodied carbon component of the building. So there is a point where if we remove the PV from this particular project, we would be essentially carbon neutral in the material side. But with the PV, it does actually have significant impact on the overall upfront carbon. So there's always a payoff between the renewables carbon side and the batteries, things like that, and then the energy savings just from using materials and not needing PV in the first place. So it's really important to be aware and conscious of that balance, at least from the embodied overall total carbon impact of the building on site and the boundary conditions, which is a very complex conversation. But it's fun to explore, especially in this project, and to see what real large-scale zero or very low carbon buildings holistically can work. And with that, you know, I like to think of this project, for myself at least, as the Passive House is a form of optimism and design, that it provides the critical pathways to really understand what the true short-term and long-term impact of buildings, especially if we look for adaptive buildings that can work over time with minimal inputs. In this case, you know, integrating a immigrant culture from climate change into a city that was built of immigrants. Most of our cities are going to be going through this radical transformation, if not already. Many of them are already stressed for housing. So the idea that we can build buildings that are a net benefit, both socially and from the carbon standpoint, is very much based on the idea of following the metrics, being quite thorough in the way we can design buildings. And for me, at least personally, I found the Passive House is extremely adept at that process. So thank you very much for your time, and I hope you guys all had a great conference, and I'll enjoy answering questions with you.